we're going to talk about absolute value functions, and this will seem a little bit more confusing than it needs to. But I think once you see what it looks like in decimals, it might make a lot more sense. At least the text might make a lot more sense. Okay, first I want to remind you that when dealing with absolute value functions, and that's this module we're working on right now. Where's my guy? Come on, guy. Oh, for crying out loud. It's not working right now. So we're dealing with absolute value functions. This is really important right here. This part right here. The absolute value function is a type of piecewise linear function. So it's actually a piecewise function, and it essentially takes two lines and puts it together, the positive slope and the negative slope of the absolute value. So you could write it as this: f of x equals a times the absolute value of x minus h plus k, where a, h, and k are constants, okay? F of x, it's got to be 0 because it's got to be a positive value because it's the absolute value coming through. So that's going to be greater than or equal to 0. Now, the vertex is either the lowest point or the highest point of a function, and essentially it's the corner for absolute value. Like, what is she talking about? So let's just talk about it. The parent function looks like this. I mean, is a f of x equals absolute x, and so it's x for greater than or equal to 0, or it's the opposite of x if x is less than 0. Obviously, if it's a negative number, it's got to be positive. It's a V-shaped graph, and the domain is all real numbers, and the range is all negative, non-real numbers, so it can't be negative. Now, blah, 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 this is all stuff we'll look at in a second, okay? If the k is bigger than 0, or if it's less than 0. If it's bigger than 0, you're going to go up. If it's less than 0, you're going to go down. That's the k in terms of this guy here. K, think of y. Don't ask why. I'm not sure why. Kentucky. There's why. Okay. Now, if you think about this with the horizontal translations, it's what the h is doing. If the h is bigger than 0, it's going to be going to the right. If it's less than 0, it's going to be going to the left. However, be very careful when dealing with that function, because I would look at it like this. Essentially, what's happening is the actual function is x minus h. Watch out when you have a negative, because then it's like a double negative, and that will make sense in a second. But let's go ahead and I just want to talk about this graph on the decimals. Not that one. This one. Where's decimals at? Not yes. Okay. Here's our basic absolute value of x. This is the parent function. Now let's go ahead and we're going to change this up just a little bit, and I want to find something of x. Okay. I want to see what happens when we go ahead and we take x plus 4. Nope. So what you'll notice there, what happens is that it's shifted to the left. So essentially it's x minus a negative 4. So I'm actually going this direction. So what I'm dealing with this, with my h is my horizontal, that's how I can remember it, h is the horizontal. When I'm dealing with that particular move, it's going to go this many units to the left. This gives us our direction. So this will tell us if we're going to the left or to the right. Now, if it was a minus 4, it's going to take our parent function and shift it to the right. So plus 4 is one thing, minus 4 is another thing. Okay, now let's talk about vertical stretches. What if I took this guy? I said, you know what, guy? I'm going to take you and I'm going to double you. Double as in 2. X plus 4. What do you think is going to happen to him? You would be correct if you thought, hey, he's going to get, whoop, he's going to get narrower. So here's my parent function here. Right, this is the parent function right here. I shifted him over to the left 4 units by having plus 4, let's say x minus a negative 4, going to the left 4 units. Now, when I double it, it's going to get stretched. It's a vertical stretch coming up through here. He's getting skinnier, getting pulled up. Okay, he's going to go twice as fast. So essentially, if I'm looking at it this way, from this graph here to this graph here, this has a certain slope. This slope is a negative slope going down. Well, I'm just saying, I'm going to take your slope, I'm going to double it, so it's going to go quicker. Here's my positive slope going up. Say this rate of change is 1 over 1. Now I'm multiplying it by 2, it's going to go up faster. So in a sense, we're saying to our slope, hey, we're going to double you. In this case, double. If I want to make it, let's make it 3 times. I'm going to let's make it 3 times. Okay. If I triple it, it's going to get that much tighter. Look how fast higher it went up. So it's more obvious. Here's my I horizontal shift, horizontal slide over here to the left, and then I'm going to triple it going up. Now, let's say, for example, I'm going to mess with its vertex. Oh, why are you making capitals? Stupid computer. Now, I'm going to take the vertex. I want to move this sucker up. Let's move them up 5 units. Okay, what do you think is going to happen? What do you think is going to happen when I move them up 5 units? I hit +5. I just said the answer, didn't I? I'm such a slow typer. Ready? Boom. There it is. Okay. So I went up from here at -4. I moved them up 5 units. Now don't forget this graph is there you go. 1, 2, half graphs. Okay, this is 5 up here, so you're able to see this through. So if I'm moving him up 5 units, it goes up that direction. So I'm dealing with the absolute value graphs. Essentially what's happening is I'm going to mess it first of all with the horizontal movements. So this comes part here, is this number here, my h. Then I'm going to mess with the slope, that's the a, okay. Then I'm going to mess with the vertical, that's the k, okay. So those are different ways we mess with vertical and horizontal movements. Again, just to refresh, here's our parent function right here. I took my parent function and I shifted 4 units to the left by adding +4 to it. Now, if I just subtracted it instead, he'd go to the right. Okay, think of opposite directions. I'll go back and make that a plus. Okay, so then I took them and I tripled it. Okay, I took this is a slope here, negative slope here, -1/1, now multiplied by 3. So it's going to be faster. It's going to go up to the vertical numbers faster. It's going to vertical stretch. Way up there. This is because I'm doing it to the outside. Okay, I'm not doing it to the inside. It's a vertical stretch. It's a movement on the vertical because I'm doing the outside of the x. Okay, outside of the function. Now, here, in this case here, we decided to take our entire function that we had so far and we're going to shift it up 5 units. This is plus. What if it was a -5? What do you think would happen? What would happen? Right, he drops down. Okay, if it's a -5, he drops down. Okay, because that's up and down. It's plus going up. Minus, he's going to drop down. Okay, now, what if, let's get cray, shall we? Let me get rid of these guys here for a second. What if I took our graph, either one of them, and I multiplied this or made this by -3? What do you think is going to happen? What do you think? What do you think? Boom! If you said he turned upside down, you're right. Turn that frowny face upside down. If I took my absolute value function, parent function, upside down, boom. So I made I want the opposite of the absolute value of our parent function. That's how I got that. I want the opposite of 3 times. That's how it happened. Because it's on the opposite side, it's able to go down like that. Okay? So we went one direction. We had the graph become vertically stretched where it's going to go ahead and get closer to. But what do you think is going to happen if I do 1/2 x? There you go. It got wider. What if I do 1/10 x? Or 1/11 x? Way wider, right? It's just not going to get there faster. Now what if I move them up? I'm going to move them up. What's going to happen here? Oh, he just moved up. Went up 4 units. What happens if I want to move them to the left? Well, I should go like this then. Move them to the left. Hang on. I said one thing and wrote the other. Move them to the left. Okay, that's +6. Move them to the right. -6. Left, +6. Right, -6. Oh, I just don't know what I did with him. He's gone. Hang on, don't go anywhere. Boom, there it is. Okay. So hopefully you understand. That gives you a little bit of idea. We'll play this a little bit more today on the movement of the graph. And this is called a dilation, by the way. We're dilating this guy as he is moving because he's on the outside of that. I think I said he was being vertically stretched, and it's not. It's dilation in this case. So I do apologize for that. It's a dilation for sure. Okay. All right.